Okay, so today I want to talk about the process of how you can register, log in a user. I want to look at the client-side code for building a form and submitting this data to the server, and then how you can take that on the server and actually encrypt or hash the password so that you're saving a hashed version of the password that can't be just opened and read as a text file. All right, so let's jump into it. We've got our form here, two different forms actually, one for registering a user, one for logging a user in. And if I come in here, like I've got one that I've already tested with, so Steve at work, and I'm going to use the same password for every single call. And here's what happens. Okay, this worked. This sent a call to the server. It created my user and then sent back a response. And in the data that came back, here's the user that was actually created. So this is my encrypted password, or my hashed password. And you can see right here, I wouldn't normally send the hashed password back to the client. This isn't something we normally do. This is just for demonstration purposes. But this string right here, this hashed version, there's actually information inside of here that we can read. This $2b talks about the algorithm that's being used to hash the password. The number 13 talks about how many rounds of hashing that are taking place. It's 2 to the power of 13. That's how many times this is looping through and hashing the password. We've got the first part, which is the salt being used. It's an extra little piece of data that's unique for every single password. And then the resulting hash of the password is the rest of this thing. So this is the type of string that's going to be saved in the database. So when the person comes to log in, and we've got the same username and password, and I say login, okay, great. I sent the request. It compared to what was in the database, came back and said, yes, everything works just fine. Okay, good. So this is working. So let's take a look at the code. Inside the HTML, I have here a form. This is my register form. And the login form's got the exact same structure. The only difference between the two forms is the forms themselves have a different ID. Because I'm using the same form fields, email and password, I decided to use the same class name. I can't use the same ID multiple times on the same page, but I can use classes multiple times. So the ID of the form is how I'm going to differentiate between the two of them. So I've got one for register, I've got one for login, and they just have the different IDs on the form itself. Down inside my script, I'm adding a click listener to the two buttons, the register form and the login form. Now those do have unique IDs, the buttons themselves. One's going to call do reg, one's going to call do login. So registering and logging in. Let's look at the register first, and we'll go through the whole process. We'll look at the client side, and then we'll look at the server side. So the registering, I'm getting the email and password values out of the form, and then I'm putting them into an object. So I'm creating an object with two keys, email and password. Those keys are specifically chosen because that's what the server side is going to expect. It's going to be looking inside the JSON data that gets uploaded for something called email and something called password. If it was expecting different names, I would have to use those different names here. Register. This is the endpoint. So I'm going to be sending something off to my server. My server is listening on port 4000. So inside of here, you can see I'm calling send data. I've created that object. I've set my endpoint to the register one, and then I'm passing my object, the endpoint, and this is the name of the function that I want to call when I get a response back. It could be success, it could be fail, but for the success one, this is what I want to call. If it works, call this function. So we'll just minimize this one so we can look at the send data function. Passing in the user object, the endpoint, which was register. You can see this is the URL that I'm sending, and then this is the last part of that URL, the word register. I'm creating a header object to say that I'm going to be uploading JSON data. So it's going to be a JSON object that I'm uploading, or a JSON string rather. User, that was the object that I sent in. I'm going to stringify that and set that as the body. The headers will have the thing set to say, hey, I'm sending up a JSON string. And then the method has to be post. If I leave it as get, which is the default, I can't upload body. This property right here does not work if the method is get. You can only send a body if you're using post or put, patch, or delete, but you can't use it for the default, which is get. Fetch. This is how we're going to upload it. So we're going to take this request object that we create, we're going to upload that, and then the response that comes back, we're going to assume that we get back a JSON object. The server is set up to always send us back JSON. So unless there was something wrong with the network transmission, I should be getting a JSON object back. The JSON could be an error, it could be a success, but I should have a JSON object. So if there's a network failure, then this is going to jump to the catch, which is right here. This catch is going to call a function called failure if there was a network problem. Or if what came back wasn't JSON, if it's like some other weird server thing that comes back, that's also going to cause an error, which will jump down to the catch. Error objects have a message property, and I can count on that. And my error objects, my JSON error objects that are coming back from the server, are also going to have a property called message in them. And that way, this function is going to work, whether or not it was some sort of native error or whether it was one of the ones that I intentionally sent from the server. So content, this is the JSON content, this JSON string, or the object that we create from the JSON string. This method right here will create the object from the JSON string in our response. If inside of there's something called error, I know it's one of my intentional ones coming from the server, and I'm going to call that failure function again, just like here. And I'm going to pass the error object inside of my content. So this content object, if it's got a property called error, that's what I'm going to send in here. If there's something called data inside of that content, I know that it worked, and I'm going to call my callback function. Now I don't have a function called callback. What I have is right here. Whatever was passed in, which if we go up here, was register success. This register success function get passed into this parameter. Now I can call this. I can put the parentheses on the end of it and call it. And it's going to call this function. So we're going to call that register success. And that's down here. It's going to do the alert, you've been registered. And it's going to console log out the data, which was the new object that was created. All right, so let's jump over to the server now. Now I've got this whole thing. I'm going to save this whole thing as a repo that you can download, and you'll have both parts, both the client and the server. I've got them saved in their own folders, just like this. So inside the server folder, this is the package.json file. This is my script that I'm using to start it up. So I'm specifying a port number, and I'm using the node monitor package to run my app.js file. What this does is it just restarts the server. Every time I make a change and I save the change, it'll just restart it. So if I were to come in here and say add a space and save, you can see that it automatically restarted it for me. Dependencies. Well, I'm using Express. That's for my server. Cores is something that I'm using in Express to add on the support for cross-origin resource sharing. NodeMon, we just talked about that. bcrypt, this is the package that we use for actually hashing the password. And back in the browser here, I've got a link. I'll put this down in the description, the link to this in the description for you. This is the package that does the work of actually encrypting the password or hashing the password. So we'll be using that in our script. So we can close that one now. App.js. Inside of here, you can see I've got my standard. Okay, I'm bringing in Express. I'm starting up Express as my app. There's cores being brought in. I'm going to be using cores right here. I'm using express.json, which means every request that comes to my server, I'm going to be looking to see, hey, is there a body? And if so, get the JSON out of that body because I want to be able to use it, or turn the body into an object. Take the string and turn it into an object that I can work with. Users. This is my array. Instead of working with a database and adding all the code for that, what I've done is I've just created a file here called data.js. It is a variable called users, which is an array. Inside of that, I'm going to have a series of objects, and they're all going to look kind of like this. There'll be an ID, which is just a timestamp. There's an email. That's the one that the user types in when we register. And then there's a password. So this is just a sample password. I did the encryption and then I pasted it in here just to have one in to show what it's going to look like. Then we export this array. So we bring that into here. Now I've got an array called users, and that's what I'm going to be adding stuff to. Instead of talking to a database, I'm just going to add items to this array. Every time the server starts, well, I'm back to just having that one user in the database or in the array. Now here's the bcrypt stuff. Now bcrypt, we're bringing in that package that we have in the dependencies in package.json. Salt rounds. This has to do with how many times we want to sort of go through the hashing algorithm with the password. Down here at the bottom, I've left some notes. This is actually from the bcrypt node module page. These numbers right here, we want to specify. Now I wrote up at the top rounds equals 13, or salt rounds equals 13. What that's going to do is, it means on a processor, roughly this speed, this is approximately how long it's going to take to do the processing and hashing of the password string that you give it. So it's not 13 times it runs it, it's 2 to the power of 13. If it has to do it that many times, this is how long it's going to take to hash one password. 14 will take 1.5. 31, 2 to 3 days. So you can see as the numbers go up, this jumps up quite a bit. At 8, you've got, I can do 40 of these things per second. At 31, 2 to 3 days for one hash. So it gets progressively slower and slower. So why do we want to do this? Why do we want to slow down our code? Well, it's to prevent things like a brute force attack. If somebody is trying to experiment, they say, okay, I've got an email address that I know is valid, and I'm going to try a whole bunch of different passwords to see which one actually works. Well, you don't want them to be able to slam through 10,000 possibilities per second and figure out very quickly what the password is. So we want to slow them down. Every attempt that they make is going to take about a second. This is going to slow it down. It makes it a little bit harder. Anything that you can do that's going to make it harder for somebody to hack in and guess the password, you want to do it. And that's the purpose of this salt and the salt rounds. Okay, jumping up to our register. So here's our two endpoints. With our Express app, we're saying somebody's posted something to this URL, localhost 4000/register. The request object, because we used Express JSON, this request object has a property called body, which will be the object that we upload. Remember that thing back here in the script? We were creating our object right here. So there's something called email and something called password. That's coming from the browser. Into here, we will have rec.body.email, rec.body.password. So when I register, first thing I want to do, I want to make sure somebody does not already have the email address registered. I'm going to go use the array method find. I'm going to loop through all the users in the array, and I'm going to compare the email that they sent me, rec.body.email, to the one that's in the array, user.email. If I find a match, then this will be the object from the array. If it didn't exist, if that email address was not already used, this will be null. It's going to be undefined. I don't have a value here. So if we don't find a match, that's when we're going to do this. Now what I did right here was I just put in a hard-coded string for the password just to make that first thing always work when I tested it in the browser to demonstrate it. So I've hard-coded a already hashed string. That's why it came back so quickly as well. we're going to replace this with the actual call to bcrypt.hash. I don't want to do this. I don't want to give everybody the same hashed password. I want to actually use our bcrypt. Like this. So the bcrypt hash method, it needs to know two things. What is the password that you want to hash? Well, that's the rec.body.password. And then, how many times do you want to loop? How many salt rounds? Okay, so we're going to say that we want the salt rounds to be this variable right here. And by putting it in a variable, I can reuse the same number anywhere that I need to. There we go. So that's going to be standard, the number of rounds. This is important. I need to know how many times to loop through in order to do a comparison later on. If I just pick a random number here, or I pick a really big number, great. I can slow the user down processing this. But when I go to log somebody in, I have to be able to take the password that they gave me and run it through this same process. I have to do the same number of rounds in order to compare it. So here we go, the salt rounds and the password. This will actually give me the pass hash. And this is an asynchronous thing. Like I said, it could take 1 or 2 seconds. So we have to wait for that. We can't just automatically jump onto the next line of code. This is what will encrypt or hash the password. Encrypting and hashing are two different things. Just as a little aside, hashing a hash value is something that went through some sort of mathematical process and it comes out looking like gibberish, like this. So we get some string that looks like this at the end of the process. I can never go back from this to the original value. Once it's been hashed, I can't unhash it. It's just, there's no way to do that. That's the nature of the mathematical formula that it's going through. With an encryption, you get a string of gibberish like this at the end, but you can get back to the original value. And the way that you get in and get out of the encrypted value is you need to have a key. There needs to be some sort of key that you use along with the formula to encrypt the value and get the gibberish, and then use the same key or a different key to unencrypt and get back to the original value. We're using hashing. It's just what we're using right here. We don't have to use encryption. We don't have to use hashing. Just hashing is what we're using here. It's an easy one to implement. All right, so here's the user object that we're creating. This is the one that we're going to put into that users array, and that's what we do next, users.push. We put our new object into the array, so it's saving it to the array that was inside this file. Now, we're not actually updating the file. Remember, if we restart the server, once we make a change like we have here, and I save this, like right now there's a change that hasn't been saved. If we watch down here, when I save this, it restarts it. When it restarted it, it put that array back to its original starting point, which was this. We're not actually making a permanent save. Everything that we're doing is in memory. Okay, and then I'm writing out the list, the full array, just so I can see it in the console here. I'm not sending it back to the client or the browser. I'm not sending them a list of all the users. I'm just writing them out here in the console. And then I'm sending a status 201 to say, yep, I've created a new user, and the one that I just created, that's what's being sent back. So there's that data property, and the data property will be the new user that we created. This is what we're writing out in the console. Okay, so that works. The register works, and we're creating new users. If I jump back to the browser here and I register somebody, so we'll say Steve at work with whatever password that is. Let's just make it ABCD. So that password, register, there we go, it's created, and here's the hash. And we can see that this hash is different than this one. It does have the 2B and the 13. 2B and the 13, those two parts are the same, but the rest of it is going to be unique. All right, now, For the login, well, I have to update my code for the login to work. Right now, my post login function, I'm just accepting everything and anything. So we have to update this. We'll do the same thing here. We'll loop through and try and find the user where the email address matches. Okay, great. I've got a match. That means you sent me an email that does exist. Now this brings up a little bit of an issue. If you don't find a matching user, you could immediately send back a response. But that is going to tell the person who's logging in, hey, when I find an email address that actually exists, it takes me a couple of seconds to get a response. When I send up an email address that doesn't match, I get a response almost instantly. So there's a difference there. And that's a way that somebody could use to determine whether or not email addresses actually exist in the database. Once they know what the email address is, they're halfway to getting in. We don't want to do that. So regardless of whether or not the email address exists in our data, we still want to slow the person down. We want it to take the same amount of time either way. Okay, so rec body password. This is the one that's coming from the browser. User match password. Well, user match is the one that's inside of the data. So we've got the one that's been hashed. And this one is the plain text one. Now, I'm not using HTTPS here. You should be using HTTPS. Anytime you're doing anything with usernames and passwords or money, always use HTTPS. It's a best practice for pretty much anything that you're going to do online. Because I'm running this on localhost, I'm just doing a demo, I'm not using HTTPS. Real world, you should be using HTTPS. Okay, so I've got the two passwords. The one that came from the browser, and the one from the data file that has been hashed, the one that looks like this down here at the bottom. I'm going to use bcrypt compare to find out. This bcrypt.compare is going to take those two values, and it's going to take the plain text one and run it through the same encryption process, and then it will compare it to the other one. So, password did match. You can see I just hard-coded it to true to start. We need to use our bcrypt.compare function like this. This is also going to be an asynchronous thing because it's going to take that second or two. So we want to make sure that we do an await. Now, with the await, we have to make sure that our function is async. Same thing up here. I already had that in there. With await, I need the async on my function. Okay. Now inside the compare, we're going to take the plain text one, the submitted password, and then we're going to pass in the saved password. Now, you'll notice here I'm not sending in the, let me close this off. I'm not sending in the salt rounds. Why is that? Inside this value, it's something that looks like this. By looking at these first two parts right here, the 2b and the 13, bcrypt already has that information. If you say this one and this one, we need to know if they're the same, it can take this and say, okay, I know which algorithm to use, and I know how many times I'm supposed to run through the process. 2 to the power of 13, that's how many times I will take this, and I will use this algorithm, I'll run it through it 2 to the power of 13 times, and then, if the string that I get back looks like this, yes, I'm good to go, I'm going to say that yes, they do match. I already know that the email matched, now I know the password matched as well. So I can send back whatever it is that I'm going to use. If I'm using JSON web tokens, I would send the token back in something like this. So my data object has a token property. That token property is going to have the token right here. So I just put a blank string in there just to do sort of a simulation of what it would be. If the password doesn't match, I'm going to send back this, my error object. Instead of data, I'm sending back error. Error has a message. And it doesn't tell them which part didn't match. It just says username or password didn't match. Now, the else right here has to do with the user match. If we didn't find the user, this is where we want it to still take that same amount of time. So I'm taking a fake password. I'm doing 2B, same number of salt rounds, and then just a big long string. This obviously will never be the result of an actual process of hashing it. So my fake pass and the submitted pass, I'm just going to run through that. These two are never going to match, so I don't have to do anything with this result. I just have to run the process, and I have to add the await to slow the person down. This is just to slow down the process. That's all. And then we send back the error saying, hey, same problem. I don't know if the username or password didn't match, or email or password didn't match. All right, saved. So now, if we jump back to the browser, let's do this again. Let's say steve@themovies.org, ABCD, register. Good, that worked. There's the hash password. steve@themovies.org, and not the same password. We'll try that. Invalid username or password. Okay, great. So I got my 401 error. If I change this to ABCD, there we go. We got our pretend token. I'm now logged in. So that works. And that is how you work with this. So like I said, I'm going to put all of this into a code gist for you. You can, or not a code gist, but a code repo. You can download that, play around with the code. It's got everything that you need to do these experiments. If you have any questions, feel free to leave them down below. I will answer as many of them as I have time for. And as always, thanks for watching.